Welcome to Astronomy Daily, the podcast, your gateway to the universe beyond our blue planet. I'm your guide on this interstellar journey, bringing you the latest and most fascinating discoveries from the farthest reaches of space. Stay tuned as we uncover the secrets of ancient meteorites, probe the atmospheric mysteries of Venus, and dive into the cosmic significance of the Milky Way in ancient Egyptian mythology. With the cosmos as our backdrop, we begin today's odyssey through the stars, all here on Astronomy Daily, the podcast.
The Astronomy Daily podcast.
Imagine a rocky voyager from the dawn of our solar system, embarking on a journey through the cosmic wilderness. This is the tale of the Winchcombe Meteorite. Nestled in an English sheep field in 2021, it tells a story that predates history itself. An international team of researchers, uniting from institutions across the globe, has deployed an arsenal of sophisticated analytical techniques, ones usually reserved for samples collected by pricey space missions, to unravel the Winchcombe Meteorite's complex narrative. This analysis has transported them back to a time when it existed as an ice-bound dry rock, only to experience a metamorphosis through the thawing of its icy heart into a muddled aggregate, a cyclical tale of breakage and reformation. These scientists were afforded the rare opportunity to study the Winchcombe sample in exquisite detail due to its prompt retrieval, just hours after impacting Earth, thereby evading contamination from our planet's atmosphere. Through their work, which has been meticulously documented in the journal Meteoritics and Planetary Science, we've gained an intimate understanding of how water once swirled within its parent asteroid, profoundly altering the minerals that compose this carbonaceous chondrite. The Winchcombe Meteorite is a pristinely preserved member of a rock family that emerged during the solar system's infancy. These rocks bear minerals imbued by water, holding clues to the mysteries of how planets, including Earth, came to be, and perhaps even offering answers to the origins of Earth's own water. But the history of Winchcombe transcends its watery past. The researchers' findings suggest that this meteorite was repeatedly smashed to bits, then pulled back together, a testament to the turbulent environment that is space. Dr. Luke Daly and his team's discovery of carbon-rich carbonates in this meteorite challenges our prior understanding. They propose that the asteroid from which Winchcombe hails may have hoarded a vast quantity of frozen CO2 before its fiery plunge to Earth. This insight could elucidate the grand carbonate veins barring the surface of asteroid Bennu, as glimpsed by NASA's OSIRIS-REx mission. The narrative of Winchcombe Meteorite is more than just a puzzle over billions of years old. It is a testament to the persistence of the cosmic order, a brutal history etched into a tiny rock, now a beacon for human curiosity and intrinsic to piecing together the vast mosaic of our solar system's origins. In the face of rigorous budget constraints and a labyrinth of technical challenges, NASA is taking a step back to reconsider its approach to the highly anticipated Mars sample return mission. This mission, which aims to bring back to Earth soil samples painstakingly collected by the Perseverance rover on the Martian surface, has been no small feat for the space agency. However, with costs ballooning and the complexity of the project spiraling, NASA is at a pivotal point, urging a reimagination of the strategy. As the agency issues a call for proposals that promises to reshape the program, it's a clear signal that innovation and harnessing proven technology are now at the forefront of this mission's trajectory. This strategic pivot aims to diminish development time, decrease risks, and more importantly, cut costs. Quite the formidable task when planning to launch a rocket from another planet's surface for the very first time. This stark redesign was sparked by an independent review highlighting gaps in the original plan, namely, unrealistic budget expectations and an ineffective organizational structure. Now, with congressional cutbacks throwing a wrench into an already tight budget, the pressure is on for NASA to deliver a more financially feasible solution, one that doesn't compromise other significant explorations, including ventures to Venus and Titan. NASA envisions this recalibration could truncate the ever-expanding expense, initially projected at $5 billion to $7 billion, but expected to surge up to $11 billion under current designs. Moreover, the mission's return timeline could potentially be pushed from the 2030s to 2040, which has prompted the agency to also weigh the possibility of leaving some of the 30-plus collected samples on the red planet. What stands before NASA now is not only a meticulous reconsideration of the current Mars mission plans, but an ardent whirlwind of innovation. And as NASA's top minds grapple with redefining such an important mission, one thing remains certain. The quest to bring Mars closer to home is as alive as ever, but it must now be pursued with a prudent fusion of ambition and cost-effectiveness. In a groundbreaking discovery, Europe's intrepid BepiColombo spacecraft has revealed startling new information about our neighbor Venus as it journeys to its ultimate destination, Mercury. During its flyby, the probe observed an abundance of gases, including carbon and oxygen, being stripped away from Venus's already fragile atmosphere. This data offers us previously unseen glimpses into the dynamics at play in the atmospheric erosion of the fiery planet. What makes Venus particularly vulnerable is the absence of a stable intrinsic magnetic field. Earth is fortunate in this regard, as our magnetic field acts as a shield, preventing our atmosphere from leaking away into space. Venus, however, is left unprotected, its atmosphere subject to the whims of solar winds. BepiColombo's instruments detected ions, charged particles, being aggressively removed from the planet by solar radiation, propelling these molecules at velocities so remarkable they overcome Venusian gravity, casting them out into the cosmos. This observation of expatriated ions raises intriguing questions about planetary evolution, especially for a world as enigmatic as Venus, with its thick carbon dioxide-dominated atmosphere. The mystery deepens as we consider the planet's lost water and how these atmospheric escape mechanisms might explain its arid state today. Venus once harbored vast amounts of water, and understanding how it transformed into the dry world we see today has significant implications for planetary science. Studying the shifting constituents of Venus's atmosphere takes us one step closer to reconstructing its climatic past and potentially its initial habitability. The BepiColombo mission, although primarily focused on Mercury, proves that a spacecraft's journey can be just as revelatory as its destination, as this fleeting encounter with Venus has demonstrated. The invaluable insights gained from this mission are not just about Venus, but contribute to our holistic understanding of planetary atmospheres and their evolution across the solar system. As BepiColombo inches closer to Mercury, its sophisticated instruments continue to beam back findings that have the potential to reshape our cosmic perspectives. This recent Venusian revelation is merely a glimpse of the wealth of knowledge that awaits as the mission presses onward.
The Astronomy Daily Podcast.
The vast expanse of the night sky has always been a source of wonder and mystery, and our ancestors looked towards the heavens to make sense of the world around them. Ancient Egypt, a civilization known for its monumental achievements and advanced knowledge of astronomy, was no different. While much attention has been given to how they saw and worshipped the sun and planets as gods, recent studies are casting a new light on the significance of the Milky Way in their cosmology, specifically its connection to the sky goddess Nut. Nut was often depicted in Egyptian art as a star-spangled woman arched protectively over the earth, personified by her brother Geb. She had the critical role of shielding the earth from the chaotic waters of the void, which can be interpreted as the endless expanse of space. Additionally, she played a part in the daily rebirth of the sun, which was believed to set in the evening only to be swallowed by Nut and then reborn from her in the morning. Astrophysicists at the University of Portsmouth have recently posited that the Milky Way may have represented the outstretched arms of Nut during the winter months and her backbone during summer. This aligns with the appearance and position of our galaxy in the sky, suggesting that Egyptians might have seen the Milky Way as a physical manifestation of the goddess herself. The studies suggest that Nut's celestial role extended beyond the symbolic. She was also seen as a guide for souls transitioning to the afterlife, correlating with the migration patterns of birds, an observation that resonates with the beliefs of other cultures who attributed similar spiritual significance to the Milky Way. This revelation not only deepens our understanding of ancient Egyptian mythology, but highlights the cultural importance of the Milky Way, a celestial feature that may have been overlooked in past interpretations of Egyptian lore. It's a reminder that even as we delve into the mysteries of the cosmos with modern science, there are historical perspectives waiting to be rediscovered and appreciated in our endless night sky. The dawn of a new era in astronomy is upon us with the advent of the Rubin Observatory, a state-of-the-art facility that is set to propel our understanding of the cosmos to new heights. This cutting-edge observatory, perched on a mountaintop in Chile, is engineered to capture the vastness of the night sky like never before, delving into mysteries that have long captivated scientists and stargazers alike. At the heart of Rubin Observatory's mission is an ambitious quest to map the heavens in unprecedented detail, revealing the ghostly influence of dark matter as it perturbs stellar streams. These streams, delicate ribbons of stars, gracefully wind their way through the galactic neighborhood, carrying with them the secrets of gravitational interactions and the sculpting forces of our universe. Dark matter, the elusive and invisible substance that binds galaxies together, leaves subtle but detectable disruptions in these stellar formations. The Rubin Observatory's sophisticated instruments are poised to observe these effects, providing a new window into the nature of dark matter and its role in cosmic evolution. As the observatory scans the skies, it's expected to generate a deluge of data, capturing the positions and movements of billions of celestial bodies. This treasure trove of information will not only shed light on dark matter's disruptions, but also contribute to a myriad of other research areas, such as the expansion rate of the universe, the properties of distant galaxies, and the cataloging of potentially hazardous asteroids. The Rubin Observatory stands on the brink of transforming our understanding of the cosmos. Through its powerful lens, we may finally glimpse the intricate cosmic dance of dark and luminous matter that orchestrates the structure and destiny of our universe. As we eagerly anticipate the observatory's completion, the astronomical community buzzes with excitement, ready to unravel the mysteries that have remained just beyond our grasp. The journey ahead, illuminated by Rubin's revelations, is sure to deepen our connection with the stars and the enigmatic dark matter that weaves the fabric of space-time. Thank you for joining us on Astronomy Daily, the podcast. It's been a pleasure bringing the universe a little closer to you. As the stars fade into the day's light, remember that our exploration of the skies continues online. Visit our website at astronomydaily.io to catch up on back episodes. Subscribe to our free daily newsletter and delve into our blog posts. Today's space news is constantly unfolding, and we make sure you won't miss a celestial beat. Our podcast is out there, waiting for you among the stars on Spotify, Apple Podcasts, iHeartRadio, or wherever you choose to tune into the cosmos. Plus, you can always stream directly from our website, putting the universe right at your fingertips. Until next time, keep your eyes to the skies and your curiosity boundless. This is Anna, your host, signing off and saying bye-bye until next time.
The Astronomy Daily Podcast.